Hey everyone, Douglas here, and welcome back to the MMT Macro Trader in this market research update. And I got a good one for you today. I have some work that I want to show you, some research that I want to show you that I have been piecing together for about the better part of 6 months now, really. But really the last 2-3 months, I have been put a lot of effort specifically into this project that I want to dive deep into. Now, I made a Twitter thread covering exactly what it is that we're going to talk about last week. I posted that last week. But the Twitter threads, usually this stuff will go up on Twitter first. So if you're not following me there, follow me on Twitter. Link in the description below. But usually this stuff will go up on Twitter first. But Twitter has a broader reach, broader engagement reach, but the problem is I can only get so deep into kind of all the details that I would want to, given the fact that it's Twitter. So it's a bit surface level, but we're going to go deep into everything that is that I want to kind of explain, express with the research that I've recently been putting together on deep learning and MMT. So what's the idea here? The main idea is, or the main question is, can we build a deep learning model, a deep learning neural network using only core MMT data, sectoral balance data? I'll explain why this is all important in just a second, to predict the unemployment rate. And the reason that we would want to do this is the mainstream, whether it be kind of the monetarist angle or the neoclassical angle, would really say that kind of core MMT sectoral balance approach really probably shouldn't have any predictive element to unemployment. But the MMT idea is that, yeah, if you withdraw the government surplus, which is the private sector saving, eventually that creates an output gap. And the only way that output gap can really get fulfilled is if you expand the deficit of the private sector. And of course, through the research of people like Steve Keen and building on top of Hyman Minsky, we know that's a very unstable system. There is a lot of instability, as the financial instability hypothesis that Minsky put together would tell you. And eventually, that indebtedness need on the private side eventually rolls over, and then you get a huge spike in unemployment. So it's kind of the unemployment story from the base to unemployment story from an MMT standpoint. Again, the mainstream, whether it be the monetarist flavor, the neoclassical flavor, maybe even the Austrian flavor, they're all going to have reasons why they would disagree with the MMT side. But the question is, okay, MMT has a proposal. We have a hypothesis that if the government spends sufficiently to close that output gap, and they make sure that they, maybe whether it be through a job guarantee or just making sure that there's sufficient spending to meet the savings desires of the private sector, that unemployment should be lower. And if that gives way, then that could set up kind of a fertile situation for unemployment to take off. But does the data say that? Can we learn from the data to predict some sort of outcome? I think that is really the question at hand. That's exactly what I set out for. And of course, I'm making this video, so we probably got what we were looking for. But I want to go through all the steps and kind of explain why it is that I think this whole endeavor is really exciting, and I definitely think it sets the stage to use this sort of deep learning approach, not only on unemployment data, but on market data, stocks, and the broader financial economy. So that is where that's where we're going to go for this video. And I guess let's jump right on into things, and I'll show you what it is that we piece together. So this model uses only the core sectoral balance data, the private sector surplus or deficit, public sector spending surplus or deficit, and then the rest of the world or their current account balances, classic sectoral balance chart, and it is predicting the unemployment rate. And I purposefully constrained the data only to the sectoral balance because I wanted to not just create something that we threw everything at to try and predict unemployment. I wanted to see if it was specifically, if we could build a model specifically to predict unemployment given the sectoral balance data, to kind of go towards proving, although it doesn't fully prove in the philosophical sense MMT, but it certainly gives a lot of credibility to the MMT hypothesis. So that is what we set out to do, and I'll go ahead and pull up my Jupyter notebook here and go over what it is we did. What I have on the screen right now is the actual network that I pieced together. Here is the model itself. I used what's called an LSTM, recurrent neural network. That's long short-term memory. Recurrent neural network is a type of neural network that is pretty much built for a time series, LSTM. Specifically, its kind of claim to fame where it really steps up is with data that is nonlinear, dynamical, complex, that has a time series that isn't necessarily built for just a pure regression, but instead needs some insight into those kind of nonlinearities. So that is why we chose an LSTM. And you can see we build it out. It's a pretty robust model. We have a total of 143,000 parameters. We have 3 hidden layers, and then the final layer is the dense layer, which is the activation, or the linear activation layer, which is doing effectively a final regression prediction of unemployment. And what we're actually predicting with this model is not what unemployment is going to be today or next month, but actually what unemployment is going to be 1 year out. So that's going to be really important. We're actually trying to see what is the unemployment rate going to be 1 year from now. As it turns out, that is about the sweet spot in terms of all the prep that I did with the data when you're going through what's called feature validation, when you're trying to test the various features being the kind of the data stream that you're putting into the model. It seemed to be that we would probably hit the best outcome about a year to 18 months out. And so this is training to understand what, or to try and learn what the unemployment rate is going to be 1 year out. A couple other things too, for those of you who might be familiar with deep learning, that I also want to point out is we went ahead and added 2 forms of regularization: kernel regularization, the L2 on each layer, and then we also did dropout as well. If you're not a deep learning person, this might not mean anything to you, but one of the things that deep learning models will do is they will figure out a way to cheat. They're going to do exactly what it is you tell them to do. And so with regularization, with dropout, we take away the ability for these deep learning models to overfit. In the deep learning world, that's called overfitting. And we want to make sure that there's no overfitting here, because what we're really trying to do is validate that the model that we built has what's called generalization, or generalized learning, that it's able to take new data that it hasn't seen and come up with a generalized kind of guess as to where whatever output it is you're trying to predict actually is, as opposed to just kind of purely memorizing what the test data is relative to what the test outcome is. So I want to be clear that we made every effort possible to ensure that we had layers of regularization to diminish the possibility of overfitting. A way to kind of think of deep learning models and how they learn is, if you can remember back to math class, you get your math textbook and all the even answers were in the back of the book, and then the odd answers were the ones that they didn't give you the answer for. Obviously, the test data is kind of synonymous with the answers that you have, so that's the test data you get. But obviously, one of the things you could do if you were just kind of a lazy student, you really didn't want to put the effort in to learn it, is you could just look at, if you had the odd answer that didn't have the actual answer, you could just look at the even problem. Maybe just move a few digits around, because usually they were close enough, and then you'd come up with the right answer, even if you really didn't learn the principles underneath. Regularization helps that that potential for the deep learning model that can do effectively the same thing. It helps it so it doesn't get stuck doing that, right? It takes away some of the ability for the model to overfit. So now that we understand what our model is, how it's constructed, the question is, how did this thing perform? And after training for 7,500 epochs, going through the entire model 7,500 times, giving ample training for learning, we were able to achieve learning. So the first thing, before I show kind of the actual predicted versus actual unemployment rate given the data, I want to look at first, did we actually get learning? And what we were looking for is particularly the orange line and the red line to push lower. When you train a deep learning model, you give it both the training data and validation data. The training data, it gets the answer to. It knows what it is that it's trying to train for. When we see the final results, what we're going to see is the training data, or the prediction fits the training data perfectly, and it better, right? That means it's doing what it's supposed to do. But what we're trying to see is we give it some validation data where it's taking a guess, essentially, on the validation data. It doesn't know the answer to the validation data. And so it uses that validation data along the way to show the person who's built the model, hey, I'm actually learning. So what we were looking for is the validation loss and error to push lower over time while the model continued to learn. If the validation error and loss starts to take off mid-training, we know it might be overfitting, but we never saw that. We continued to see the actual training data continue to get stronger with the validation loss and error data as well track. So we were able to conclude that we had a robust model that was achieving generalized learning. And now onto the fun stuff. Let's scroll down to the final prediction versus the actual results. As you can see, pretty stunning results. Everything in the grade and light blued out is the training. Everything to the right is the test data. So anything to the left, it didn't get the answer. It had to predict that based only on the sectoral balance data of what unemployment is. And what you can tell is it has a very clear understanding that sudden spikes of unemployment might start happening when the data gets in a certain way. I think after looking at this, the post-COVID spike did get this model to be a little jumpy. It was anticipating a lot more unemployment heading into the dot-com bubble. But that doesn't matter. Remember, when I set out to do this, as I explained when I set out to do this, that it wasn't that I wanted to build a model that perfectly predicts unemployment. What I wanted to do is constrict the data to core MMT data to see if there was any predictability, any forecastability of unemployment from that core MMT data. And we were undoubtedly able to see that. We made sure that our model was set up in a way that it wouldn't overfit, that it would achieve generalized learning, and we got the result that I think we would expect that we would get. Which just, I mean, I'm thrilled. I'm absolutely thrilled by this result. It is better than I expected. And the question might be, okay, well, that's great, but what would it look like if you gave it some other data set that it couldn't learn from, right? What's a baseline for effectively non-learning? Which is a great question if you were thinking that. So what I did is I built the identical model, but instead of giving it sectoral balance data, I gave it local weather and population data, which really shouldn't have much of any correlation to unemployment. And what you can see is exactly what you'd expect if there's nothing there to actually learn from. And I do want to show that we actually achieved learning, right? We achieved the same look in terms of our validation and training error and loss. So it learned, but what it learned is there's just nothing useful in that data. And so you can see the weather data and the population data just gives effectively a straight line that wiggles a bit, which is, I think, kind of what you'd expect given the data set that it was given. So we were able to validate that, one, we have a robust enough model that can learn from the data that we're giving it, and that there's actually it's not overfitting, and that it's actually learning something about unemployment because of the sectoral balance data that it's learning to train from. And given another data set, without that, we end up getting effectively a straight line. There's just nothing to actually distill from the weather data, while there is from the sectoral balance data. So yeah, to me, this is very exciting. It really, I don't want to use the word proves, probably a little too much of a leap there, but it definitely validates everything that MMT has been saying for quite some time using a deep learning approach in admittedly kind of a novel way, but I think a useful way, given where deep learning has come from years ago to today. I think we can without a doubt conclude that we built a robust enough model to really handle the data that we're giving it, without thinking that the results should somehow not be interpreted for what they are. But I did promise that at the end of this video, I'd have some exciting stuff to share. So if you've made it this far, congrats, you're going to see some really cool stuff. One of the things I've been doing since I posted the thread on Twitter is try and make this model even better, even bigger, and see if we can get some better results using a slightly more sophisticated kind of cutting edge model. and I have that to show you. So what the model is you're seeing is actually a convolutional neural network that then feeds into a bidirectional LSTM, as opposed to just the unidirectional LSTM that was used in the prior model to then predict the unemployment rate. And as you can see between the two, I'm going to just switch between the screens here. You can see that this convolutional plus bidirectional LSTM is quite a lot better at predicting unemployment. And the idea here is by adding that convolutional layer. Now, you might have heard of convolutional neural networks. These are the type of neural networks that are quite popular in image recognition. Certainly, with the explosion of certain image tools online, it's definitely in the vocabulary of many now. So it uses convolutional neural network and ties in essentially what it's seeing as kind of the feature creation part that it then feeds into the LSTM model. And the idea here is that we're going to allow the neural network to get even more insight into how the data is structured before we ever send it into that kind of nonlinear regression LSTM model. In other words, it's really the neural network that gets to decide how is it that it can best see this data, as opposed to us just telling it about the data. And the results were absolutely fantastic. Then the thought is, and I'm sure you're thinking this right now, and this is where the fun really begins. Hey, Doug, you're the MMT macro trader. I mean, understanding unemployment's great, but come on. Can it do anything with stocks? Can this approach be used for stocks? And of course I've aimed it at stocks. And I'll show you the chart in just 1 second, but I do want to qualify with a couple things. One, unemployment, especially given the way unemployment happens, that it's usually a cascading event. Once you get to a certain level, there's no turning back. You're going to get a big runaway spike in unemployment. Compared to stocks, which are just volatile, there are a million different things that can drive markets in any direction at any given time. A far more difficult endeavor to predict. But the question still remains, given core MMT data, sectoral balance data, can we get any generalized learning for some sort of forward return in the stock market? My expectation was not too much, but I did have some hope that we would end up seeing some learning, and I will jump to that right now. Here's the 1-year forward return of the S&P 500. Again, everything on the right, it got to learn from. Everything on the left, it's actually guessing in real time. And I got to tell you what, again, given the very constrained data set that we gave it, this model was able to predict with some clarity what's going to happen into the future with stock data. Again, the overall volatility, the kind of the variance of the swings, undoubtedly it struggled with, and I kind of did that on purpose. You can see going back to the other model, it was able to fit very closely with the data that it was training on. I made sure that it had more of a generalized approach as I was training this, that it would kind of just understand kind of the ebb and flow of the market, and was able to do that, I think, with quite spectacular results on the prediction side of things. Obviously, we have hundreds, if not thousands, of features that we can add to this, and many different approaches that we can continue to take heading forward. But this model that we have built up is certainly showing some promise heading into the future for deep learning and using an MMT macro approach to understand where markets are heading. And you might be wondering, okay, so when is it good enough? At this point, or when is it good enough to use? At this point, my thought is once it gets better than the Bayes model that I've already built for understanding kind of the core dynamics of MMT as they apply to markets, once it gets better than that and we can prove that out, this model will be alive, and we'll be using that going forward. All right, so that's what I have with regards to the deep learning endeavors that I wanted to share for this video. Obviously, we're going to have a lot more to share very soon. And if you've made it this far, you're probably an active investor, active trader. And if this sort of research intrigues you, and not only do you want to support what we're doing, but you want to get access to this research and everything else that I've built up, head on over to our Patreon page over at patreon.com/MMT Macro Trader. I make these models, as long as they are kind of academic in purpose, available over there for all three tiers. I have a supporter tier, and then I have 2 tiers for active traders and active investors. If that's something you're interested in, check it out over at MMT Macro Trader. But the unemployment model is already up there, posted for your perusal, the Jupyter Notebook. And I even do a video, if you're not familiar with Python and Jupyter, on how to open that with a free Google Colab account and see the results for yourself and go over the code. So if that's something you're interested in, check us out over there. Anyway, that is all I have for today. So until next time, good trading, everyone, and we'll talk to you then. Bye-bye.